The next unit in the course is titled Continuous Time Linear Time-Invariant Systems. In this unit we'll be focusing exclusively on continuous time systems that have both the linearity and time invariance properties. Some of the topics we'll be covering include the following. We'll be introduced to a new mathematical operation known as convolution. We'll learn about the relationship between convolution and linear time-invariant systems. We'll be introduced to something known as the impulse response of a system. And in the case of linear time-invariant systems, we'll see how various system properties can be characterized in terms of the impulse response. We'll also learn about the eigenfunctions of linear time-invariant systems, and we'll see how eigenfunctions can be exploited in order to avoid convolution in some situations when working with linear time-invariant systems. As it turns out, linear time-invariant systems play a very prominent role in engineering. And since we're going to be spending a very substantial amount of time studying linear time-invariant systems, I'd like to take a moment to explain why these systems are so important. Before proceeding, however, I should point out that the term linear time-invariant is often abbreviated by the acronym LTI. So often I'll use this acronym to save a few syllables when I'm speaking. So why are LTI systems so important? Well, the mathematics of LTI systems is much simpler than that of systems that are nonlinear and/or time-varying. Furthermore, many very sophisticated mathematical tools have been developed for analyzing LTI systems. So LTI systems are much easier to deal with than the alternative. But this in and of itself is not sufficient to motivate such a strong interest in LTI systems. Another factor is extremely important, which is the following. The vast majority of systems that engineers design and build can be approximated with linear time-invariant models. In other words, we can approximate the systems that we build using LTI systems. So the reason that LTI systems is so important is due to the combination of the above factors. First, LTI systems are easier to deal with mathematically, and second, LTI systems allow us to get the job done. In other words, they can be used to design and analyze most types of real-world systems.